The focus of this lecture is understanding the scientific research process. So in this lecture, I'll be walking through the steps of the scientific research process as well as the purpose of scientific research in the first place. So we'll start with an overview of what science is and what is the purpose of science in general. And then we'll move on to talk about different research publication sources, talk about the peer review process, and then end up talking about the types of peer-reviewed scholarly articles that you might come across in the organizational sciences. So let's start with science. So what is the role of science? Well, science is based upon empiricism. And so what does that mean? Well, empiricism means that knowledge is based on evidence or data. Or in other words, truth needs evidence or data. So in order to gain knowledge or to find or seek truth, we need to acquire evidence and data. So that's really at the heart of what we're considering to be science here. So what are the traditional goals of science and the scientific process? Well, typically we can think of science revolving around 4 different goals. And these are to describe, predict, determine the cause, and explain or understand some phenomenon of interest. So, for example, if we think about an organizational or business context with different employees or job incumbents, we might think of these examples. So if our goal is to describe something, a particular phenomenon of interest, we might be describing, for example, demographic characteristics of job incumbents to understand maybe the level of diversity within our organization or within specific units. And this is descriptive in nature, as the name implies. Now, the next goal is predict. And an example of that in the organizational context is to predict job performance based on scores on a selection test. So you can imagine that you have applicants who have come through the selection procedure. Let's say they've taken a cognitive ability test. Well, what we can do is actually try to see if scores on that cognitive ability test actually relate to future job performance. And in that way, we can develop a model. And then in future samples that we might come across, we can apply that model or that equation to see, okay, we found with this new sample, they have these scores. Everybody has these different scores on cognitive ability. And let's see what their likely predicted job performance is going to be should they be hired in the future. Now, the third goal is determine the cause. And with the cause, an example would be determining whether a new training program actually improves skills. And we could actually use a randomized controlled trial, or in other words, a true experimental design, let's say, where we have a true control group and we have a treatment group, which would be the new training perhaps. And then we randomly assign employees to one of those 2 groups. And then afterwards, we give them all a post-test or a post-assessment and see whether people learn more in the new training program or whatever we're considering to be the control or the comparison group. Now, the 4th goal of science is to explain or to understand something. So let's think of this example. We could explain how informal leaders emerge in a leaderless setting. And so try to explain the process, for example, or the how or the why something comes about. That's really at the heart of explanation and understanding. And sometimes this is when we start looking at intermediary mechanisms, for examples, like mediator variables or understanding conditional boundaries or moderators that might be at play. So now let's dive into the scientific process, which sometimes you'll hear referred to as the scientific method. And there's different variations of this, but they all kind of boil down to these steps here. We start with first formulating the hypothesis, then we create some kind of study design to actually test this hypothesis we've come up with, and then we acquire or collect data as part of that study design, and the data will be used to, again, go back and test that hypothesis. We analyze the data we've collected, we report the findings, and as part of this analysis and reporting part, we determine whether or not we found support for that hypothesis. And then usually based on what we find, that leads to new hypotheses, new questions, and so forth. And so the whole process becomes iterative, and there's this feedback loop where it cycles back on itself. And that's really at the heart of science, is it's very iterative. There's a lot of repetition and replication at play, hopefully. So when you think about the scientific process or the scientific method, it's good to take a step back and realize we're really just talking about good, solid, old-fashioned problem solving. Okay? And so you could think of these are the equivalent steps in what we'd think to be just rigorous problem solving within an organization. And that would be first, in terms of formulating a hypothesis, that would really equate to identifying and defining the problem and formulating questions you might have. In terms of designing the study, this is where you determine how to collect the evidence or how to collect the data. Because remember, science is about empiricism. It's based in this idea that we acquire knowledge based on evidence or data. And then collect data, that's fairly self-apparent or self-evident. That would be we collect the evidence in order to try to solve this problem or answer the question that we formulated. And then we go on to analyze the data, which would, in a problem-solving framework, we might say we're evaluating the evidence, for example. And then ultimately, in terms of reporting the findings, this is where we decide on a solution and report out the findings. And often we'll refer to this as storytelling process and maybe also the implementation or a deployment process as well, depending on how far you go with this. Okay, but at the end of the day, just think of the scientific process as being rigorous problem-solving. So let's take a walk through the scientific process with a concrete example of a study that my colleagues and I published. Now, this study was published in the journal that's called Human Resource Management, and the title of this study is Overqualified Employees and Insecure Managers: Implications for Employee Career Outcomes. And so again, this is something my colleagues and I published relatively recently. And for that reason, let's walk through this and see how we apply the scientific process here when working with data from a real organization. Okay, so let's start with that first step in the scientific process, which is to formulate the hypothesis. Well, let's walk through one example of a hypothesis we had in this particular article. Well, Hypothesis 3 reads, manager job insecurity will moderate the relationship between focal employees' perceived overqualification and voluntary turnover such that the relationship will be more positive when manager job insecurity is high. And so the idea here is that we contended that employee perceived overqualification, so if people believe they have more knowledge, skills, abilities, and other characteristics than is required for their official position that they're in, they exceed the requirements of the job specifications and the job description for their particular job, well, then the idea is that they're probably going to be more likely to turn over or quit the organization because they're probably not going to be paid at a rate that is really recognizing these additional skills and knowledge and so forth that they bring to the table, and also because they might get bored or something like that. Well, what we're looking at here is thinking of that relationship between employee perceived overqualification and their likelihood of actually quitting the organization and asking, well, what role does potentially manager job insecurity play here? So the idea being that if you have managers who are insecure with their own job, they have low employment security, they're going to be probably less likely to have resources available and attention available to support these people who are overqualified by giving them more opportunities, helping them with their development and so forth to keep them mentally engaged and all of that. Okay? And so this is the hypothesis we'll focus on. So we formulated our hypothesis. And note here in this hypothesis, it implies 3 different variables, which you see highlighted in green here. The first variable is manager job insecurity. The second one is perceived overqualification. And the third one is voluntary turnover. Moreover, the question then begins, well, how will we actually assess job insecurity and employee perceived overqualification and employee voluntary turnover? Well, I'll show you what our design plan was and what sources we actually used in terms of collecting these data and when we did that as far as the timeline goes. So this is when we moved into the next step of the scientific process, which was to design the study. And so as part of this design phase, we had to submit a proposal to our institutional review board. And then after that was approved, we recruited employees and managers from 2 organizations. And what we thought was important was to make sure that we didn't have common sources across all the different people, across the measurements or the sources of measurement. And so what I mean by that is that when it came to manager job insecurity, who better to ask than the managers themselves? So at 0 weeks or at baseline, we actually assess manager job insecurity by having managers self-report their level of job insecurity using an established scale or measure. 3 weeks after that, we then surveyed the employees and we had them report their own perceptions of their own overqualification in their job. Okay, so we have a 3-week lag here. And then ultimately, 24 weeks later, we gained access to the organization's records, and we found out how many of these people had voluntarily quit or are turned over versus how many were still in the organization 24 weeks later. Okay? And so there you can see we have essentially 3 different sources here. We have the manager's ratings of their own job insecurity, we have employees' perceptions of their own overqualification, and then we have organizational records of the employee's voluntary turnover. As the next step in the scientific process, we collected data. And so specifically, we deployed that measurement plan and that design that I just showed you. And we needed to first recruit managers and employees, and we did so from 2 organizations in Turkey. We had 54 managers that participated in the ultimate sample, and as well as 124 employees that were working for them. After we collected those data and deployed the study and acquired our data, then it was time to analyze the data. Now, this actually has a nested design to it because we had employees nested within managers. And for that reason, we ran a multi-level logit model, or a multi-level logistic model as it's sometimes called. And we actually ran what's called a cross-level interaction within that. And we found a significant cross-level interaction, which is how we tested our hypothesis 3, which I previewed a little bit ago or described a bit ago. And here's a visual of what we found here. And so you can see on the y-axis, we have the probability of voluntary turnover ranging from 0 to 1 here. And then we have employee overqualification from low to high here on the x-axis. And then our z variable, our conditional variable, our moderator variable here is manager job insecurity, high versus low. Okay? And we operationalize high versus low as plus or minus 1 standard deviation above the mean in terms of job insecurity. And so what did we find? Well, we actually found support for that hypothesis. And we found that the relationship between employee overqualification and the probability of them quitting or leaving the organization was higher when they had a manager who was more insecure in their job. Okay, and so we see that represented by this solid line, which is the high manager job insecurity line right there. So what did we do in terms of reporting out the findings, the last stage of the scientific process? Well, we presented the findings initially at the 2019 Academy of Management Conference, which is a large academic conference that focuses on organizational behavior and human resource management topics, among other things. Now, after we had presented that, we actually were able to publish this in a peer-reviewed journal, which is called the Human Resource Management, which I mentioned earlier. So that's how we've deployed things so far. The next step would be to actually translate these into more practical implications that we could communicate to organizations and specific organizations and give a little bit more specific guidance in terms of what practically do we mean by, or what practically can you make of these findings from our study. Okay, so again, that's just a way of previewing and reviewing what the scientific process actually looks like by walking through each of these 5 steps here. So let's talk now about this role of replication and why this is an important part of the scientific process and science in general. Well, think of it like this. You could have one original research study, like the one I just presented to you that my colleagues and I published recently. Or you could have a bunch of original research studies all focusing on the same thing. So I presented one of our hypotheses, which was looking at, does manager job insecurity moderate the relationship between employee perceived overqualification and their voluntary turnover? Well, imagine if we had 9 different studies, as visually illustrated here, all looking at the same thing with different organizations and so forth. This can help us triangulate and get closer to the truth here. And the reason is that any one study is going to be imperfect. There's no perfect study. There's always sampling error and measurement error and so forth. And if we're really trying to generalize the findings or understanding when and under what conditions the findings will generalize, we really should be replicating. And so that should be one of the goals of science in general, is to replicate. And so if we can find a synthesis, someone that's gone through a research team and synthesize all these findings, which I'll talk about in a little bit, that is really, really valuable. And so this is where we start talking about really thinking about replication and programmatic research as well from researchers in terms of trying to really kind of pick apart a given phenomenon of interest to understand it at a deep level. Now, we're going to have more confidence too in a particular finding if it's been replicated. Okay, and so hopefully that's fairly intuitive. A single study, it could be it could be a fluke, but it also could just be something that's very idiosyncratic to that particular subpopulation or sample that we grabbed for that particular study. Or maybe it was done in a specific industry with a certain type of employee in the case of organizational research and science. And so for that reason, we'd want to then replicate it to have a better idea of under what conditions, or does it always generalize to other situations. Now, another important aspect of science is what we call scientific skepticism. And so what is scientific skepticism? Well, this is the idea that you evaluate ideas using careful logic, and the results are you use careful logic as well as evaluate ideas based on the results of systematic, programmatic investigation as well, and hopefully that investigations in which there's been multiple investigations by different research teams and that we find that there's been replication at work there, we're going to have more confidence there. But we should really take into account whether or not things have been replicated, whether they're systematic, whether there's been programmatic investigation, as well as the quality of each of the individual studies and investigations. And so this is what scientific skepticism is really about. And we want to also, when applying skepticism in this context, we want to challenge findings and ideas in a constructive manner, okay? And we want to focus on what are ways in which we could take what's been known already or what's been learned and then extend it or expand upon it or do incremental research, or say, well, here's where we think the shortcomings have been so far. Let's say that we've only looked at these findings, like the hypothesis that I showed you earlier. We only tested that so far in a study of Turkish employees. Well, we could challenge those findings and say, well, will this generalize to, let's say, a North American population? And so that would be something that's constructive. It's a critique, and it opens the door and points to a future direction, which is let's try to replicate this finding in a North American organization with North American employees, for example, or anywhere else in the world for that matter. So what I like to think about when it comes to science is it's really this delicate balance between we want to have high levels of scientific skepticism and exercise that at will, and we also want to make sure that we have enthusiasm too. We don't want our skepticism to necessarily curtail our enthusiasm and our excitement that we have for the scientific process and our intellectual curiosity that we might have. So it's important to find that balance between these two things of skepticism and enthusiasm. So now let's shift gears and talk about the research publication sources. Let's start first by the types of sources you're likely to encounter in the organizational sciences. So generally you can think of two broad categories: refereed versus non-refereed, or sometimes peer-reviewed versus not peer-reviewed, types of articles or scholarly sources you might come across. So what's the difference? Well, I'll walk through the peer review process in a little bit here, but briefly, peer review means that typically there's been at least 1, 2, maybe 3 different reviewers, sometimes more than that have looked through a study and they've evaluated it, and then they help decide whether or not it has merit and whether or not we can find the findings to be trustworthy enough to actually be published. Okay, so they look at the methodology, they look at the theory, and so forth. Well, often these reviews are blind as well, which means that, and they're often double blind, which means that the reviewer doesn't know who or what research group they're evaluating or reviewing in terms of the research. And then the scholars or the researchers who submitted this article, for example, they don't know who their reviewers are, okay? So within that refereed category of peer-reviewed articles and sources and so forth, we have what is called scholarly research or academic research, and this tends to be very focused often on theory development and furthering theory and building theory and so forth. And really kind of understanding what is at work here, understanding and explaining a phenomenon, as well as trying to predict and describe and so forth. Well, we talk about practitioner peer-reviewed or refereed sources. These tend to be ones in which it's really often taking what we know from the scholarly research and academic research and then trying to translate it in a way that's going to be directly applicable to applied audiences and people, let's say, working in organizations, and explained in a way that managers can take that information and then translate that or just apply directly to their own employees or the way that they manage people within their organization as an example. Now, within the next category of non-refereed or not peer-reviewed types of sources, these include things like book chapters, textbooks, white papers, blogs, and these either don't have any type of review, or if they do have some type of review process, it's not at all, or it's not akin to what we would classically think as a peer review process or a referee process. Because if it is, maybe you know who, in these contexts, if you do get a review, maybe they're friendly reviews, you know who's giving the reviews, or you don't have to act on the reviews. You can just look at them. Let's say in the case of a textbook, you might get reviews from people from around the country, different faculty, for example, but you don't necessarily have to make changes to anything. You can just see, okay, how did they receive it, for example? And blogs usually never have any kind of review process, although I'm sure there's some exceptions to that. The idea, though, here is that the more trustworthy sources and the evidence that's presented within refereed or peer-reviewed sources is going to be more trustworthy. And hopefully this is intuitive, because it should follow that if it's been through rounds of revisions and you have independent people evaluating and reviewing the process, both in terms of theory and methodology, as well as interpretation and even potentially practical implications, that's going to result in a more trustworthy publication than something where that does not occur. So now let's talk about what the peer review process looks like. What's the prototypical peer review process? Well, typically this is how it unfolds. Although not necessarily exactly like this in all cases, this is often how it'll unfold. You have your researchers, your author team, they have a manuscript, and this manuscript describes their theory, their methodology, their analyses, their discussion, and so forth, all the important components of their paper that they've written, and they're going to take that and they're going to submit it to a journal, and then the first round of defense is that the editor is going to review it. And the editor will look at it, and typically they'll say it's either going to be a desk reject or it's going to be sent out to reviewers. If it's a desk reject, it's often because either the paper that was submitted is just not really a good fit for the journal in terms of the phenomenon of interest or the topic that it's focusing on, or it could be that it doesn't meet the journal's requirements in terms of length and things like that, or appropriate levels of rigor. But let's say that a manuscript's been submitted, the editor reviews and says, hey, I think that this looks like it could have a path forward. Well, then the editor sends it out to a review team. So this might be 2 to 3, maybe 4 reviewers that they send it to who have expertise in some area of the paper. Sometimes they'll send it to people that all have theoretical expertise that's relevant to whatever the manuscript covers. But it's often common too that, especially if the paper's using a more advanced type of statistical methodology, for example, statistical analysis, that they might send it to someone who has expertise in that statistical method. So after that, the reviewers are going to review, and then the reviewers are going to submit their reviews back to the editor, the action editor, and then at that point, the editor is going to take those reviews, and the editor will decide whether, based on all the reviews that they've received back, whether it's appropriate to reject the paper at this point, this manuscript, conditionally accept it, which is fairly rare after the first round here, or at this point, they might request a revision. And at this point, those reviews get sent back out to the authors. But let's focus here first on this idea of what happens if you were to conditionally accept. Well, in this case, in this rare case, conditional acceptance after the first round or first submission, the authors would then get the manuscript back. They'd see what comments were there. Usually these are very minor if there's a conditional acceptance. They submit, the authors send it back with those corrections, and then the paper is published. But what happens if a revision is requested at this phase? Well, then the authors get it back. And usually if there's a revision, that means that it's going to take more time, and there's likely going to be another round of revision after this. And so the authors are going to revise, respond to reviewer comments, change the manuscript, maybe even collect more data, for example. And then This process could repeat again as the authors resubmit for another revision. The reviewers will look at it again. They give the feedback. The editor then decides, do we accept it, conditionally accept it at this point, or do we send it out for another review? And sometimes you can go through 2-3 rounds of revision, maybe more in some cases, before a paper is finally published. And so if you can imagine that there's sometimes months and sometimes even a year or more between these different steps, it can take several years sometimes from start to finish for a paper to be formally accepted into a journal, or the person has to then submit it to a different journal and so forth and start the process over again if they were rejected from the first. Okay, so let's talk about types of peer-reviewed scholarly articles now. Okay, so thinking just within that refereed bucket, those types of articles and those sources in which we're going to have more confidence and find the findings to be more trustworthy, what are the different types of peer-reviewed or refereed scholarly articles? Well, I mentioned this earlier, this idea of an original research study. An original research study is a study where you're collecting original data or using data in a new way, okay? And so this is often where you're going to be thinking about answering research questions or testing specific hypotheses using available data. A theory paper, on the other hand, this is going to be when someone's looking at an existing theory or multiple theories and maybe focusing on synthesizing these theories qualitatively or deriving a completely new theory based on their review of the literature that they've seen so far. Typically, a theory paper is not going to have original data. If it did have original data, then it would also be considered to be an original research study as well. But typically, a theory paper will result in something like a series of propositions, theoretical propositions that essentially is volleying up these propositions to future researchers to then test those propositions with future data collections and future original research studies. Now, the third type that I'll talk about is what we call a review or a synthesis paper. And this is when there's been enough research on a particular area, topic, or phenomenon of interest that then a team of researchers or a single researcher will come in and they'll review the entire literature. And there's two general ways that we can do this. We can do this as a qualitative review. And in a qualitative review, we're going to describe what we found across all these studies. Are the findings consistent across these studies? Do they differ? Are there different types of studies in which we find that this relationship, for example, or this difference exists, but in other studies we find that it does not exist? Now, with a quantitative review, which we often refer to as a quantitative synthesis or a meta-analysis or a meta-analytic investigation or meta-analytic review, these are going to be where if we have enough data and we have enough findings in terms of statistical test of associations or differences or whatever the makes sense in the particular context, we can then go through and actually synthesize those numeric findings. And so what do I mean by that? Well, let's take a look at first what the importance of synthesis is, and then I'll show you an example of what a meta-analysis or quantitative synthesis actually looks like. So let's say that we have our phenomenon of interest, and so we do an original research study on it, okay? That's great. This is what I've mentioned before. It's a good starting point, but there's all sorts of sampling error, measurement error, and so forth that any one study is susceptible to, and any original research study is not going to be perfect. So what's better is if we have replication and a bunch of people looking at this same phenomenon of interest across different locations, different types of organizations, for example, and then that way we can try to triangulate and find, okay, what is really the true finding, the true association, the true difference, the true effect that we think really exists with respect to this phenomenon of interest or this particular topic. And so this is why synthesis is important, is figuring out a way to describe the results across these studies coherently. And there's always going to be variation. So the findings are often not going to be consistent across all the different studies, even when you're looking at the same, essentially testing the same hypothesis over and over again. So this is where meta-analysis comes into play. It's a type of quantitative review or quantitative synthesis. So what is a meta-analysis? Well, it's a quantitative synthesis of findings from multiple original research studies investigating a common phenomenon or a type of association or difference, or whatever the case might be. So as I mentioned, it's often referred to as a meta-analysis, but sometimes might see it referred to as quantitative synthesis, a meta-analytic investigation, or a meta-analytic review. So let me walk you through a toy example here of what could be considered a bare bones meta-analysis by Hunter and Schmidt. And so the idea here is I'm just going to show you some hypothetical values from 5 hypothetical studies, and I'll show you essentially what a meta-analysis is doing. This is an oversimplification in terms of modern meta-analytic techniques, but it'll give you an idea of what's roughly happening behind the scenes. Okay, so you can see here we have our table. We'll have each row will represent a unique study. The phenomenon of interest, or the topic, the relationship, the association we're interested in here is the relationship between a person's age and their level of happiness. Let's say that the prevailing theory is that as people get older, they get happier. And then we'll have the sample size represented by N here. And I should say R represents, little r there represents a correlation coefficient, a Pearson product moment correlation. And then what we're going to do with this bare bones meta-analysis is compute what's called a sample weighted correlation here. Okay. And so to get to that sample weighted correlation, I'll walk through the steps, but ultimately what we're doing here is we are weighting each one of these correlations by the sample size. The idea being if you have a larger sample size in which that correlation was estimated, it's relative to the total sample size that you have across all the studies, then we're going to be more confident, or that study carries more weight. Okay, so let's take a look at this. So here are the 5 studies here. Here are the 5 correlations. Here are the 5 sample sizes from each one of these studies. Now, note that in general, the association between age and happiness in terms of the correlation coefficient is positive, but to illustrate that sometimes we might have some unexpected findings. So in this particular study, we actually found a negative association. We don't know if this was statistically significantly different from 0 or not, but still, this shows that there's often heterogeneity in terms of these studies. And here are the sample sizes. You see these vary quite a bit as well. This sample size for study 1 is the largest. So this, as you'll find out, this particular correlation coefficient here is going to have the most influence. It's going to carry the most weight as we apply the sample weighted correlation formula here. Okay, so let's, and as I noted, pay close attention here because here this one is a negative correlation for study 4. Okay. So often the type of notation we'll use is a K is going to represent the number of studies, so K equals 5 here. And how do we calculate the total sample size, the pooled sample size for across all 5 of these studies? Well, simple. We're just going to add them all up here. And the sum here happens to be 1,458 people or individuals or employees, whatever the type of individual was looked at in these 5 studies. Okay, let's now look at the first study. So how would we apply a sample, or how would we create a sample weighted correlation here? Well, as you can see with the formula, first we need the R value, the correlation value, and we're going to multiply that by the sample size for this study divided by the total sample size. Okay, so N divided by N total. And so we're saying 0.315 times 623 divided by 1,458. And so the sample weighted correlation here is 0.15. We do the same thing for study 2. Sample weighted correlation is 0.05. Same thing for study 3, it's 0.03. Same thing for study 4, and you'll see that, note how it was a negative correlation here, negative 0.11 for study 4, but the sample size was only 78, which relative to the others was quite a bit lower in terms of this, the individual sample size here. And you can see that the weight it carries is much less too. So you'll see it's only a weight of negative 0.01 here for the sample weighted correlation. And then finally for study 5, we find that that sample weighted correlation is 0.02. So what do we do next? Well, let's add up all these sample weighted correlations values here to get our corrected correlation. Our corrected correlation here is 0.24, okay? And so what we could think of this as being, quote unquote, the true population parameter, for example. So what is the true association, magnitude, and direction of the association between age and happiness? Well, here we might think that this is a small to medium-sized correlation or association here, and it's positive. So to a small to moderate extent, we could conclude that as people get older, they get happier. Okay? And so that's the value of meta-analysis here. If we had only looked at study 4 here, we might walk away with a very different conclusion. But by pooling together and synthesizing these results, we kind of get more to the truth here. And so again, this also recognizes the importance of replication. Okay, so this is our meta-analytic correlation, or our corrected correlation here you see at the bottom. And so this wraps up this lecture. And again, the purpose of this lecture was to help understand the scientific research process. Now, this was not meant to be an exhaustive review of what the scientific process is, but hopefully this gives a kind of a better appreciation for why is science important? Why is the scientific process important? How is it just like basic problem solving in many ways? And what is the research publication process? What's the peer review process? What are the different sources that you might encounter, and what are the different types, and how does a peer review process unfold, and what are the types of peer-reviewed scholarly articles you might come across? And then lastly, I really wanted to finish up with, which is what I did, with what a meta-analysis is, because this is a good quantitative tool that we can use to synthesize findings across a number of different studies that have looked at the same phenomenon of interest. So this wraps up the lecture on understanding the scientific process.